Hi, everyone. Thanks for joining us today. My name is Wael Haddad. I'm a postdoc at the NERI SimCenter, and I work at UC Berkeley. I work in the software development team. Today's webinar is about gathering data for natural hazards engineering using web automation. This webinar is coordinated by the Natural Hazards Engineering Research Infrastructures Computational Modeling and Simulation Center, and the webinar is supported by the National Science Foundation Awards 1612843 and 1520817. Any statements in this webinar are those of the presenter and do not necessarily represent the view of the National Science Foundation. So I'll give a quick outline of my presentation today. I'll start by some motivation, why we need web automation, and why we need, how we can employ web technologies in our research workflows. And then I'll give some introduction about web technologies, and more specifically, I'll talk about web APIs, what they are and how they can be useful in research. Then I'll talk about some of the relevant web services that provide data that can be useful for research in natural hazards engineering, things like hazard data or exposure data, how we can obtain them from these web services. And I'll also talk about some of the Python libraries that are available to help with this process of web automation and of working with online data. And I'll also talk about a web automation framework called Selenium. And I'll give some examples of how this can be employed to obtain tax assessor data, for instance. At the end, we will have two demos. One to show how we can use web automation to work with a data set of tall buildings in San Francisco, getting both the building information and the hazard data for these buildings. And also I'll show a regional scale or city scale data gathering exercise for Anchorage, Alaska. So let me start by some motivation. We put together this webinar to basically educate the community about some of the web automation frameworks, and we see a lot of value in them. So I wanted to give you guys some examples why web automation and web technologies and working with online data can be useful. One of the most relevant examples is working on analysis that requires a regional scale. So you're doing regional hazard or loss estimation, you're doing city scale simulation, you will need to work with a lot of data. And some of this data is available online in some resources online. So it requires us to use web automation to be able to gather all this large amount of data. So working with big data requires to use web automation, for instance. This is one example of Anchorage, Alaska. So what you see here is a map of Anchorage in Alaska with 84,000 parcels color-coded by their occupancy, which is actually a piece of information that can be very useful for hazard and loss estimation. So this can be useful when you're working with, exposure data, hazard data, or even other types of data like households. Another example, if you're working with data for your research and this data is frequently updated or changes very frequently, one good example of this is shake maps, especially after an earthquake. So after an earthquake happens, USGS produces these shake maps that takes the sensor data, the records measured from the earthquakes, and kind of interpolate the intensity measures between them. And these data products are often updated over and over again. The same happens with process ground motions, for instance. In this same example on the right-hand side, when a magnitude 7 earthquake happened in Alaska, in Anchorage, Alaska, about a year ago, there was a set of process ground motions that was available a few days after the earthquake, but some of these ground motions were changed. It was processed differently. Some of them had mistakes and so on. So if you're working with data that might be changed, then there is a lot of value in automating this process of obtaining this data from the online resource and using it in your research. This way you can go back and update your data easily, rather than just going to a website and downloading it and consuming it this way. You will have to do this process manually. So web automation can help with some of these applications. Another example, for instance, if you're working with earthquake aftershocks, and this is after a real earthquake, and aftershocks, it's kind of, they are updated in real time. There are many aftershocks that happen after a major earthquake. Again, with the Anchorage, Alaska example, the few months after the earthquakes, there were hundreds of aftershocks. And of course, another example is forecasts. If you're working with forecasts like earthquake rupture forecasts, or what they call the earthquake source models, some of these models get updated to some extent kind of frequently. So if you're working on a multi-year project, this data might be updated during this period multiple times. So being able to get this data from online resources using web automation can be very valuable. Another case is if you have a research workflow and you want to make it repeatable. So for instance, you worked doing some simulation for a building or a bridge and you want to repeat this for another building or another bridge in a different location. So if you do this process, gathering the data for this building or bridge using some scripts and web automation, it means you can take this scripts and use it for another building. So if you repeat the same process over and over again for, let's say, different assets, you're working with a set of buildings, then web automation becomes useful. So before I actually talk about web automation itself and the tools that are available to do that and some of the online services that are relevant to natural hazards engineering, I want to give some introduction about web technologies in general and just cover some of the basics. I personally didn't know much about how the web works actually a few years ago, but I started working on a cloud computing project and I started learning about the web. And the basics are to some extent simple, but I wanted to cover it in this presentation before we dive into more details. And I thought one way we can do this is to think about what happens when, we open the browser and go to the Google search engine. So we type www.google.com and we go there to do some search. And I wanted to think about what exactly happens. I mean, of course, if this is something we probably do every day on our computers or mobile devices, but I wanted to give some details about what exactly happens. So what happens on our computers is you open a browser, you type in this URL and you get the Google search page. But what actually happens is your computer sends some information to the router that it needs to go to this web page. The router sends it to your internet service provider. And the internet service provider have something called a domain name server. Sometimes you might have seen it, it's called DNS. And this domain name server will take the URL that you typed, www.google.com, and it will resolve it into a number, kind of the address of a server in Google. So it will basically give you the address of this server, and this allows your computer to directly connect to this server on the internet. So now there is a connection between you and this server, and this allows your computer to get the search page, basically. Just to cover it in a little bit more details, what happens is your computer becomes in the internet or in this network kind of a client, and it sends a request through the internet, and this request goes to the server in Google, and this server sends back a response to this request. And this response basically is the HTML document. It's kind of in a text form, and your computer, which is the client, it in the browser, it has some ways of understanding what this HTML text is, and it will be able to render it. So you end up seeing on your screen the Google search box and the search button, basically. So this is basically what happened. Just to sum it up, your computer as a client sends a request to the server, which is in Google. This server sends you back a response, and the response is most of the time in text form. So in this case, it's called HTML, but there are other cases where you request something from a server and you get other form of text, like the one we will cover today, which is very popular these days, is called JSON. So you send a request and you get back a response. It's in text form, and your computer can either take this text and render it on the screen, or as we will see today, you can actually get this response and do something else with it that's useful for the research. Just to follow up on this, and then we can ask the question, then what happens when we actually go in the search box? We type something and then we click on the search button. In this case, you you already have a page loaded into in your browser. So when you send the request to the server and you get back the response, which are the search results, let's say you write SimCenter and you click on search, so you'll get back some links to the SimCenter web page. Now, this response that you get may not necessarily be HTML, it might be in other form, but again, your browser knows how to render this and show you a list of search results that you can use. So these are just some of the basics. Just to sum up, in the web, usually we have a client, we have a server, and there are requests going from the client to the server, and usually the server respond back with some response in text form. So just to give you guys a little bit more details, I wanted to cover web APIs, which is another way of communication in the web. And before I cover web APIs, I wanted to define what an API is in just a simple term. An API usually is just a definition of the methods of communication. So it's called application programming interface, and it's basically the rules of communication between two entities. And in the web, there are what we call web APIs, which basically define the methods of communication between a client and a server when it comes to the web. And recently, there is a specific type of these web APIs that is called the REST API. And this, again, sets some standard rules of communication on the web. It uses what is called the HTTP protocol. And it defines basically 4 different methods of communication. There is, sometimes they call them verbs. There is the GET request, the POST request, the PUT request, and the DELETE request. So GET is for retrieving data, POST is for creating data, PUT is for modifying data, and DELETE is for deleting data. And just going back to the previous example that we talked about, when you go to the web browser and you want to go to the Google search page, what happens is a GET request. So your computer, which is the client, sends a GET request to a server in Google, and it gets back the response. So for the most part, for today's webinar, the GET request is what we will be interested in, because we are interested in getting data, gathering data. So we're mostly doing GET requests on different APIs. And we will see, this will make sense, maybe more sense when we go through some of the examples. But for the most part, this is what we will be doing today. But just to give you guys some examples to put this in a proper context, you know, every day when we're using our mobile devices, we are doing many of these GET, POST, PUT, and DELETE requests. And just to give you an example, imagine what happens when you use social media. So you use your Facebook app or Twitter app, and you go and write a tweet, and you click on a button to post it. So when you click on this button to post the tweet or your Facebook post, this is actually a post request. So your computer or your phone sends a post request to a server in Facebook or Twitter, and it gives it the data, and this data gets stored somewhere and it's posted. So you're doing a post request. So this is something we're doing every day without knowing really, but this is how the web works. And then if you want to go back and maybe you were writing this post, you had a typo, so you want to go back and edit it. So if you go back and edit it, you're doing a PUT request, and then maybe you want to delete it for whatever reason. So you can delete this you know, tweet or post, and this becomes a delete request. So these are the basic operations that happen with many of these APIs that we use in the web. And before I dive into more details, I just wanted to cover one more thing, which is the JavaScript object notation. As I mentioned earlier, in the web, when you do a request, we will be doing many of these GET requests to get some data. You get back the data in text form, and one of the most popular formats for this process is called the JavaScript object notation, or JSON. It's a file format that describes data in a very human readable form. And this is an example that you see here on the right-hand side. And even without me explaining anything about this, you can easily figure out what it is. based on the description of the data here, it looks like this is a building that has 3 stories. It was built in 1975. It seems to be made of wood or something, and it seems to be a residential building, and it's located at this latitude and longitude coordinates. So it's a very easy to consume format, and the way it works is it provides data as pairs of attribute and value. So you see here, each one of these data, it has an attribute name here on the left and a value on the right. So this is how JSON works basically. And then the value can be one of different types. It can be a number, like the number of stories or year built or area. It can be a string, like the name of the building or the occupancy. It can be a Boolean or an array or an object. So generally, an array is when you see square brackets in JSON, and an object is whenever you see curly brackets. Like this location is an object that have two inner attributes, basically, which are the latitude and longitude. So there are ways to even nest these different types, like this. In this case, location is an attribute whose value is an object, basically. So you can put an object inside another object. You can put also an array inside another array, and so on. So this data format is very flexible. It's being used a lot on the web, as we will see in the next few examples. And it's one of the most popular formats nowadays when it comes to working with web APIs. One of the disadvantages of this format, however, is that it's not very efficient when it comes to data storage. So the size of storing data in this form, that if we store it in a file in this form, like a text file, it's usually the size of the file is large. And this can be an issue if you store these files locally on your computer. So you can keep this in mind. But working with this data in the web is generally not a problem, because usually when data is transferred in the web, it's compressed. So this data can get compressed and uncompressed very efficiently, and it's usually not a problem in terms of transferring over the network. But once you have it in your computer, and let's say you store it in a file, it may not be very efficient the way it gets stored. So what I'm gonna do now is go through different examples and show you some of the online resources out there, some of the web APIs and web services that are available that are relevant to natural hazards engineering. And the point I'm trying to make here is to show you that some of this data is already available on websites. Maybe you can consume it on these websites directly. You can go to a website and download the data. But it's also available through APIs, so you can actually use web automation to get it directly. And we'll see some examples of this later. But one example here is the Hazards API by the Advanced Technology Council, and it's available here in this link. And this is one example of how you can call it. But before I call it, I want to tell you that if you go to the ATC Hazards website, this is actually a paid service. You can use it to get hazard information in different locations. So you can click on a point on a map and get, things like the wind hazard, the seismic hazard, and so on. And it supports different types of hazard. But what's important here is that they also have an API. And what I found out is they have some examples of how to use this API. So it's usually based on this URL, api-hazards.atcouncil.org. And then it goes into different hazards. So in this case, it's going to wind.json, and it's providing latitude and longitude. So many times, the way to use these APIs, to some extent, it's readable. When you form this URL to request something from the API, it's easy to figure out what it means. So it looks like here, lat equal some value means this is the value of the latitude, and the same for the longitude. So it would be easy to take this link and maybe modify the latitude and longitude and get data for a different location. There is some documentation of this API in the first link here. And one thing I want to point out is we will post this webinar on YouTube, and in the description we will have all the slides, a link to all the slides. So if you need to get to this link, you will be able to do that. I'll also try to maybe post it in the chat window today before we end the meeting. So what I want to point out is here is like an example of how you can use this API to get hazard data. So if we actually click on this link, the output is this JSON file. And this is basically, we are doing a GET request using this link. And this GET request defines some of the input parameters like latitude and longitude. And then the response that we're getting from this GET request is a JSON. And this JSON has an attribute called datasets. It seems to be an array because of these square brackets, and it has different objects. And what you will find is that it basically gives you the design wind speeds for this particular location for different mean recurrence intervals. So this is the 10-year mean recurrence interval, and this is the ACE 716 wind speed, and the value of this wind speed is 76 miles per hour. And I'll just show you guys as an example. If I click on this link, this will open it in the browser. And when you put this link in your browser, you're basically doing a GET request. And as you can see, the outcome of this process, the response is the text data that we get back, which is in JSON format, basically. Let me go back to my presentation. So this is one example. Another example is USGS Seismic Hazards API. It's also called NSHMP-WS. It's part of the Nature Seismic Hazards Mapping program in USGS, and they have a bunch of different web services. They have services to get the hazard. They have services to get the design maps for seismic hazards, for instance. They also have services to get shake maps after a real earthquake or for scenario earthquakes. And this is, for instance, an example of a shake map for Anchorage that shows the PGAs due to a scenario earthquake. So later on in the demos, we'll actually see how we can use this design maps web service for some of the buildings in San Francisco. So we'll give maybe a more detailed demo of one of these web services. But if you go to some of these links, you'll find a lot of documentation about how to use this web service and how to actually form these requests to get some hazard data or design maps data, something like that. This is another web service provided by USGS. It's called the Earthquake Catalog, and you can actually use it to query some of the, basically the earthquakes or information about earthquakes that happened. This map, for instance, I created from this data. It shows the earthquakes that happened near the US in 2019 with magnitude more than 4.5. This is another example of how you can use this to do a query. So if you go to the link at the top here, you will find the detailed documentation, but this is just one example. So it's trying to query this data in a format called JSON. It's specifying the start time and the end time. So from the beginning of 2019 till July 24th, it's specifying a latitude and longitude and maximum radius and a minimum magnitude. So this is actually a query I used to get information about the Ridgecrest earthquake. And the nice thing about this is I get information about this earthquake, but then this workflow can be repeatable. So every time I need this data, I can go back to that same query and get an updated data because, you know, for instance, when an earthquake first happens, you would have an estimate of the magnitude, but maybe it wouldn't be very accurate and it gets updated. So some of this data gets updated frequently, and you can use this web automation method to be able to repeat this process. I'll show you guys just an example. If I click on this, it actually, again, this is a request and I get back the response. The response actually gives me the features, basically the location of this point where the earthquake happened, and also a lot of information about the earthquake itself. So this is basically the ridge crust earthquake. So going back to the presentation, I'll show you another example. This is another example of a tall buildings inventory in San Francisco. It's available through the Data SF portal. And if you click on some of these links in the presentation later, it will take you to the website with some more information. But what I want to show you is this link in the middle here. And I want to show you something that I think might be useful. So you go to the website, you search for tall building inventory, and you get to this link. And it's a data set of tall buildings. There is a lot of useful information here about when this was updated. This was actually updated recently. And again, this is one of the reasons why this is useful, because if it's updated in September, and you work on doing some research with tall buildings in this area, maybe later it will get updated again with more information or updated information. So you might come back and retrieve this data quickly without having to do this manually. You can, of course, just come to this website and click, let's say, on view data or download it as a table or a CSV file. But what I think is useful is looking at this API. And this is why I try to maybe introduce these APIs earlier, because I'm hoping that this is something that can become useful for you to recognize that in many with the data you work with online, if you actually see that there is an API to get this data, that can become very useful. So we could have just clicked on view data and saw this data on a map or in a tabular form. But because there is an API, we can also go to this API endpoint and get this data in JSON form. Actually, in this particular website, they give you 3 different options. You can get it in 3 different formats, but I'm gonna choose JSON for now. I will copy this API endpoint and I will paste it here in the browser. And as I said, you do a request, you get your data back in text form. So this is the text I get back. And you can see that it looks like this, again, is an array of buildings. Each building has an ID. It has a polygon, which is like the footprint with some coordinates of the different corners of the building. And also I guess the address of the building, the height of this building, the number of stories, occupancy, some information about some of the materials, and so on. So there is a lot of useful information here about these buildings. And later in the demo section, we will actually see how we can use this data in Python and work with it using web automation tools. So this is another example, the Census API. And again, the documentation is in the first link, but this is an example of how you can use this Census API to get, for instance, information about the population of the states, or there is also information about, income, median income, and so on. So if you're interested in household information and this kind of information for your research, this is one data resource that you might be interested to know about. And as I said, there is an API here in this link. You can see more about the documentation, how you can define these requests. And one thing I want to do before I go to the demos is basically talk about some of the Python libraries that are relevant to this process. So one of these libraries is called requests. And basically what it does, it allows you to submit HTTP requests and get the response in Python. So you can write some Python script to submit some of these requests we showed earlier, and you get the data inside your Python script as a dictionary, and you can basically manipulate the data and work with it. And we will see this in the demo in a little bit more detail. Another tool is called the Selenium web automation framework. It's basically a web driver that allows you to control your web browser. So if you want to navigate a website to get some data automatically, and you want to automate this process of navigation, this is the tool you can use. And again, you can use it through Python, and we'll have a demo about this in a little bit. The other libraries is Beautiful Soup, which is it's a package that helps you process HTML files. So if you try to get some data from an online resource and it's in HTML form, you can use Beautiful Soup to parse this HTML and extract some useful data from it. And finally, there is a census and US Python packages which help you query census data. So let's jump into some of these examples. So the first example I want to show you guys is how to work programmatically with this data set of tall buildings in San Francisco. So we want to write a Python script that uses the requests library, and this library will help us get a list of tall buildings, maybe print them to the screen, and also we can do another request to some of these USGS APIs that we talked about earlier to get the design PGAs for these buildings. So this is the set of buildings we'll be working with. So these are tall buildings in San Francisco, and we're gonna go through this Python script with a little bit more detail. Sorry about that. So let me switch to Python and show you guys this example. So this is the first example here. And the first thing that happens in this script is it imports this Python request library. It's an HTTP request library. So this is what you will need. And using this request library, you can actually do a GET request. So as you guys remember earlier, we went to this website for the tall building dataset, and we found this API link that gives you a link. So this is the same link. So instead of putting it in the browser, I will actually just put it here in this GET request in Python. And let me show you what happens when we run this. What I'm going to do is I'm going to run this script in debug mode. So this allows me to set a breakpoint here and step through the script line by line. So the first line is doing the GET request. So now we've done this GET request, we got some response. The first thing to check when we get a response, like an HTTP request response, usually have a status code. And if this response or if this request was successful, the response will have a status code of 200. So I'm checking if the status code of this response is equal to 200 to make sure that this was successful. And if this was successful, I will take the response and basically change it to JSON format. So once I do this, I have this list of buildings here in Python. It's basically a dictionary of buildings. And I'll show you when I scroll through this list, you see I have 180 of them. There are 180 buildings in this set. And because it's an array now, Python understands that this is a list. So we can simply just do a for loop through this array and start processing this data. The first thing I will do is try to obtain the coordinates. If you guys remember when we showed this earlier, there was some polygon here. This polygon has coordinates attribute. The coordinates is an array, and it seems to have a bunch of edges, and each edge has a bunch of points. So if I go to polygon coordinates, the first element in the array for the first side and the first element in this side, which is the first point, I will get basically coordinates of one of the corners of the building. And this is what I'm doing here in this line of code. So I'm going to, sorry about that. I'm going to building polygon coordinates 0, 0, which means give me the first side of this polygon and the first point. And I'm getting these coordinates. It does have two components, the latitude and longitude. So now in this loop, when I'm looping through the buildings, I was able to get the coordinates. And this is the other request that I can do. Now that I know the coordinates, I can use the USGS design maps web service to get basically the design PGA for this point. And this is how this request is formed. You use the earthquake to usgs.gov/ws design maps, and then ASCE 716, and you give it latitude, longitude, and you're also supposed to give it risk category and site class. But for this case, I just wanted to demo for you guys that we can change some of these parameters. I hard-coded some of these values, but obviously, if you're doing this for real buildings that you're using in your research, you might be able to change some of these values to whatever is the proper value for the building. So what I'm going to do is I'm going to send this request. And again, because we send the request, we will get the response. So we need to check that the status of this response is 200. Sorry about that. And then I'm taking the response and extracting the PGA value from it. So after I do this, I have a PGA of 0.515G. So this basically is a Python script that goes through the buildings one by one and finds their location and PGAs. And we can just keep running this. And as you will see in a minute, it will keep printing on the screen for each building its ID, its location. And of course, we could have printed more than this, right? And I'm just showing you that you can work with this data programmatically. Of course, printing it to the screen may not be very useful. You can just save it in a file or use it in your research or use it to do some simulation with it or some loss assessment and so on. So this is just one way of how you can get data from the internet and using a Python script. And as I said, this process is repeatable. So if the same website publish another set of, let's say, vulnerable buildings in maybe another area, you can go and get another set of data with the same script just by changing the API endpoint that you are doing the request on. So one thing to point out here is in this request, I put here this line to delay the requests. So what happened with many of these online services is they do something called throttling. So if you keep requesting from the service a lot of data over and over again very, very quickly, it will throttle your requests, which means it will slow you down. And sometimes it would be faster if you put some delays so you're not basically doing a lot of requests on these web services, and this makes things work more smoothly. And this also just to be kind of more responsible when you're working with these services, because many of these services are shared between different people. A lot of people are relying on them. There are some software tools out there that rely on these services, so using it responsibly is important. The other thing that I want to point out is it's important to make sure that the data you're working with is open and available. So many data products that are out there might have some either disclaimers or limitations. So make sure if you get some data, make sure that it's legal to get this data, that this data is public and you're allowed to do this. Also make sure that you can share it. So sometimes some data is copyrighted, which would mean they might allow you to take the data to do your research with it, but you cannot take the data and publish it or share it with others. So it means you cannot take that data and give it to someone else, but you can get it and use it in your research. So just be aware of some of these limitations with some of the data products online, and also be aware of throttling. So if you notice that your requests run very quickly and they start slow down, just maybe add some delays so you're not abusing this web service, basically. I'll show you guys, like if I comment this line and I run the same scripts again, what you will see on the screen is that it will run very fast in the beginning and then it will start to slow down. So you see at the beginning it's running fast, and usually at some point you will see it start slowing, becoming much slower than before. Actually, it's not, doesn't seem to be doing this now, but this is usually the behavior that you get, is if you do a lot of requests at once, it will start throttling your request and slow you down. Yeah, you see now it started to slow down. In the beginning, it probably processed, 50 buildings very quickly, and then it started slowing down. And if I keep running this, because it's doing the requests very frequently, it can slow things down very significantly. So this is the first demo that I wanted to show. The most important thing, in my opinion, in this script is line number 5, where we did use the requests library to get the data for the building. So this is the first part of the script where we basically did this GET request on this API endpoint to get the list of buildings, the tall buildings in San Francisco. And then line 24, where we did this get request again with the latitude and longitude of that particular building for each building in this set. We're doing this request again to the USGS web service to get the design map or the design PGA. So these, I think, are the most important pieces of this. But as you guys can see now, it's not we're not just getting one data product from a web service. In that script, we were able to combine two services. So we're able to get data from one source and use it to get more data from another source. So that's the first demo. Let me go back to my presentation. So the next demo, I'm going to show you guys an example of a regional simulation. It's one of the test beds we're working on in the SimCenter to do some regional hazard and loss assessment for the magnitude 7.1 Anchorage earthquake that happened in November 30th, 2018. And you guys might have seen some of these pictures before. This is the damage on Vine Road that was popular in the news. Some partial damage, partial collapse in the Eagle River community. And this is the USGS shake map. And in the SimCenter, we have this test bed where we try to populate the building inventory for Anchorage and simulate the ground motion on a regional scale and do damage and loss assessment to get, less ratios and red tags. So the way we do this is basically by using web automation. And the way to do it is we try to control the web browser using this Selenium framework to get the parcel text data. And we use a processor to process this text data to get information about the building inventory. So we populate the building inventory basically using the tax assessor data. And I'm going to show you guys this in a little bit, the demo. But basically the end product is that we went from data that was on a website to data that's in a database that we have. And for each building, for instance, we can obtain a lot of useful information like the area, the number of stories, the year the building was built, the occupancy of the building, and the latitude and longitude, the parcel ID. So this is a lot of useful information that we can use for both the hazard and loss estimation. And when we did this process, we were able to do it basically on a regional scale, so on a very large scale. So we were able to get text data for 97,000 parcels and process them. And the end result was we populated this regional building inventory with 84,000 buildings. And not just that, we have a lot of information about these buildings, like the occupancy, the number of stories, and also when they were built, which is very useful for loss assessment for sure. So to do this, we basically tried to automate the process of browsing the tax assessor website and extracting this building information. And again, we did this using Python. So this is going to be my demo. I'm going to show you guys. Let me switch here. Okay, so this is the tax assessor website. So actually, if you go to the Municipality of Anchorage website, you can click on this link, search properties, and you can search for any parcel or street address or something like that. And what I found out is if I enter 0 here and I click on search, it gives me the first parcel or the lowest parcel ID. And I'll just show you guys, this is a list of different parcels. If I click on one of them, maybe not this one. Some of these parcels are actually tax exempt, so or maybe vacant lands, so they will not have buildings, but this one has a building. And you can see some information about the building here. First of all, at the top, you can see this is a residential building. You see how many stories it has. It was built in 2019. You can see the area and some information about, the garage that it has and the exterior wall material and so on. So there is a lot of useful information here that we would be interested to obtain to use for loss assessment of this, building inventory. So just going back, so what I did here is I started by opening this page. So this is the Municipality of Anchorage Tax Assessor website. So muni.org, pw, public.html. So this is the first page I got. Then I went to this box and entered 0, and I clicked on this button, Submit Search. And that gave me a list of buildings. So I can go through these buildings one by one and click on each one of them to get some information about these buildings. And when I'm done with this list, I can click on Next. So of course we can try to do this manually, but this will take a very long time. So what I'm gonna show you guys is how we can use, again, web automation to do this process automatically. So let me switch back to Python. So this is actually a demo that uses a library called Selenium. It's a web automation framework that we can use to control the browser. Usually when you use Selenium, you need something called the web driver. So in this case, I have this Chrome driver here, which allows Selenium to call the Chrome browser. So as we did earlier, I'll set a breakpoint and run this code and step through it line by line and explain what's happening. So the first thing is, of course, I'm importing Selenium because I need to use some of these features of this automation framework. The first thing is I'm starting this WebDriver.chrome. Sorry, guys. I'm going to just, yeah. Maybe scale things a little differently. Oops. Yeah, so the first line that we ran here is WebDriver.chrome. As you can see on the left-hand side, this basically started the Chrome web browser. So this allows you to start the browser from your Python script and control it. So now we want to open this website that we talked about earlier, the tax assessor website. So I have the link here and I'm doing browser.get. And this basically lets the browser do a GET request on this URL and get the HTML and render it. Then the next thing, if you guys remember, I entered 0 here and then I clicked on Submit Search. So I found out that this box where I entered 0 actually has a name. It's called par1. I think it's for parcel because this is the parcel number. So what I can do in the Python code, what Selenium allow you to do, you can find elements in the web page by name. So I can search for this element by name, and when I find it, I can send the key 0. And you see when this line was executed, this box now has the value 0. And then the next step is I want to click on the submit button. So I'm gonna step through this. I'll find the button by its name. It's called submit button. And then I'm gonna do submit button.click. And this basically clicked on the button. So as you guys can see, we can write our own Python script that controls the browser, and we can keep it looping through this whole process. So I'm gonna run it, and you can see that it's basically going into each parcel in this table and extracting some of this information like the parcel ID and occupancy. So using this process, you can automate this process of going through the browser and browsing to find elements and finding the data you need and extract it. So this is just a small script that only gets the parcel IDs and occupancy. And before I just end this demo, I wanted to show you guys how I find out that this element here is called par1. The easiest way to do it in the Chrome browser, at least, is you can right click and click on inspect. So I did right click on this input box and clicked on inspect, and it shows you the source of this HTML document. And you can see that this is a text box, input box, and its name is par1. So this is how I found out that I need to find an element called par1 in the Python script. The same with this button also. We can, what I can do is I can do inspect on this button, and you see that this button is called submit button. So this is why in the Python script I found the element called par1 and entered 0 in it, and then I found the submit button and clicked on it. And using this process, you can just automate, use web automation to go through websites and get data, as I mentioned. So as I mentioned, we use this to get data for the whole region. It included 84,000 buildings, and this whole process took maybe probably a couple of days to get data, populate the inventory with 84,000 buildings. So web automation is a very valuable tool in this kind of research workflows, especially when it comes to regional simulation. So that concludes my presentation.
Great, thank you. Well, just as a reminder to those listening in on the webinar, if you have any questions, please send those in the chat window to the moderator. Thank you, Will. Again, a few questions that came up. The first one is, are these slides available to the audience?
Yeah, let me see if I can share them. Sorry, when I was presenting, I couldn't see the meeting control. Let me see if I stop sharing this presentation. Okay, yeah, I can see it at the top now. So if I go to, I guess, the chat window. Sorry, guys, I'm not, can I, let's see, can I attach things here?
Yeah, I think you can just drop it.
I can drop it. Okay, let me drop it here. And no, it doesn't allow me.
Okay.
So is it possible to send an email out, or?
Yeah, we have the email addresses when people registered for the
and then I think we'll also post it on the video. When we post it on YouTube, it will be in the description. But right now I'm not sure is there any way to share it here? I don't see.
Okay. Well, I think maybe we'll just either post it on our website and send a link out to people who registered.
Yeah.
The next question has to do with the throttling that you encountered.
Yeah.
Specifically, what do you do to counter the throttling?
Yeah, so it depends really, but generally when throttling happens, it can be very detrimental, meaning that if you're requesting, let's say, if you're doing 100 requests per minute, let's say, like, I don't know if that's a lot or not, but let's say 100 requests. And if the server recognizes that you exceed a certain limit, it can really slow you down to, like, let's say 1 or 2 requests. But if you don't exceed some threshold, it will not slow you down at all. So you have to do some, if you think this is a problem in your workflow and it's slowing you down, you have to do some trial and error. There is not like a particular delay that would work well for you. But my suggestion is just to maybe put some small delays there. So let's say 100 milliseconds or a few hundred milliseconds. And this still allow you to get a lot of data, but without abusing some of these web services. But each web service will have may have different ways of handling this. Of course, there are even some web services out there that would completely block you if you exceed a certain limit. So many times this information is available in the documentation. Just to give you an example, the peer database on the website, in the documentation, they mention if you download more than 400, I think, records per week or month, I don't remember the exact number, but there is a certain limit. If you exceed it, you get blocked. And many of the online resources might have some of this information on the limits of using these resources available in their documentation. So in the slides, actually, all the relevant web services we put in there, there was one link, at least one link for the documentation. So if you go to this link, you will see a lot of the details, some of the technical details of this web service and its limitation.
Okay. Another question is how much quality control do you have to do on the data once you've acquired it? Is there cleaning up or scrubbing?
Yeah, you definitely need to clean up data, especially tax assessor data. I mean, any data product out there, there is always a chance of people making mistakes. At the end of the day, if you look at this tax assessor data, there is a lot of there is a lot of data that is being manually collected and entered, right? Data entry process might also be manual for many of these. So you definitely need to go back and clean things up. Just to give you an example, what we found out, for instance, is some of this data is easy to clean. For instance, we found out that you know, we're working with a data set in Atlantic City in New Jersey, and we had some buildings where, like, you will find a building that's 114 stories, and there are no buildings that high in Atlantic City. So it was most likely 14, and it was mistyped as 114. So unfortunately, some of these, maybe some of these can be also automated, but some of them cannot. So it really depends on the source of the data and how clean it is. There are some states have, they try to guarantee certain amount of quality on this data. New Jersey have a standard format, for instance, so that all the counties put their data in a standard form, but you will still find, you know, there can be still some mistakes. So there are certainly some cleaning that needs to be done. Another issue you might come across working with tax data is if you have, let's say, a condo. So like for multi-family housing or a condo, so you have different units in the same building. So you're really interested in identifying the buildings, but what you end up with is multiple, you know, tax records for the same building. And each one maybe for different unit in the same building. So you might need to write some codes to take this data and, you know, basically merge it together for a single building. So if you have a building with a condo with like multiple units in the same building, or multifamily housing or this kind of situations, you will need to make sure that you're merging this properly. And the way to do it is to detect that if these are all in the same unit, and you can add some of the attributes, like the area, for instance, will be added. Some of the attributes would be the same, like if they will all say that they are residential multifamily housing, and that's easy to handle. But then some of the other attributes will need to be added and aggregated, like the area and so on.
Okay, and then just for clarification, in the context of natural hazards engineering, you've pointed, excuse me, pointed to places to get hazard information,
Yeah.
and you've pointed to places where you can get building information,
Yeah.
but the building information doesn't necessarily contain information about the structural system that an engineer might want or need to know about.
Yes, yeah, definitely this is a challenge. So there are some information that can be useful, like some buildings you will have information about some materials, but usually this is like the external wall material and stuff like that. So structure information are more difficult to obtain. And especially, you know, the same building, it might look exactly the same from outside, but internally there are many different systems. So many times, at least for the purpose of regional simulations, what we do is we do mapping schemes or mapping rules. So we use some rules to map the building occupancy, the year it was built, and maybe the number of stories to a particular structure type or a particular structure system. And in our tools for regional workflows, we try to assume this is an uncertainty. So if you're doing a regional simulation and you're doing this for so many buildings, you will definitely end up with some uncertainty. You will not know for sure. So one way to handle this is to assume this is kind of an uncertainty in the input. But the problem is it won't be easy to get structural data for all the buildings in a region, for instance.
Mm-hmm.
It wouldn't be that difficult. Although in the SimCenter now, there are some tools that are exploring this, like using machine learning and AI to try to detect some information about structural systems. For instance, we have a machine learning tool that try to detect soft stories based on Google Street Views. And we have another tool to do interpolation. So if you know information about a group of buildings in a region, it can interpolate between them and give you interpolated data for buildings with missing data. So there might be some other tools to kind of complement what we showed today. What we showed today is just how to use web automation, but of course there are a lot of other data sources and other tools that can complement this.
Well, we've reached the end of our hour. So Wael, thank you very much for this presentation. To the audience, thank you for listening and for your questions. I would remind you to go to the SimCenter website, which is simcenter.designsafe-ci.org. And from there, you can sign up for our community newsletter to find out about other upcoming webinars. Check your inbox for emails from the Announce at DesignSafe postings that also contain information about other NERI activities, and hope to have you again in an upcoming webinar. Thank you very much, Wael.
Thank you so much.